Hello everyone, my name is Lisette van Beek. I'm a postdoctoral researcher at Lund University, and my PhD research was on the role of climate modeling in climate politics. I'm so glad that I was invited to provide this lecture, in which I will introduce you to the topic of modeling in the context of climate politics. So I start off this lecture with a quote by historian Paul Edwards. Everything we know about the world's climate past, present, and future, we know through models. Climate modeling has been absolutely foundational for how we understand the climate problem. Without climate models, we would not even know that the climate as a whole was changing. So, how come these climate models have become so prominent? How are they used? And how should we think about them in the future? These are all questions that I will address in this lecture. So, before going into climate modeling, I first want to sketch some context on the topic of climate change more broadly. So, the first part is about the climate crisis, root causes, and also how to move forward. Then I go into modeling, their history, and how they are used today. I will end with a forward looking approach, giving you some key questions to think about when using these models. So, the climate crisis. How do we get here and how do we move forward? The climate crisis cannot be understood without considering the two following historic roots: imperialism and capitalism. For some of you, this may be self evident, but it's so extremely important to keep in mind, and it's often surprisingly absent in media and policy discussion. So, imperialism is the political control of another country through exploitation, colonization, and military force. Amitav Ghosh has recently written an excellent book about this in 2021, using the history of the nutmeg to illustrate how colonization is linked to the climate disaster. Capitalism, an economic system in which private individuals or businesses own capital goods. It's driven by profit and growth and relying on fossil fuel combustion. My colleague here at Lund University, Andreas Malm, has written this book recently called Fossil Capital, explaining how this economic system has come into being and has become entirely reliant upon fossil fuel combustion. In fact, not just our economic system, but our society as a whole is completely entangled with fossil fuels. Some have argued that we therefore live in a petroculture. In many ways, our ways of living and being are connected to the fossil fuel industry. So we're living in a fossil fuel society. Fossil fuels are not only shaping society in material ways, think about plastics we use, the food we eat, the cars we drive, but also our culture, our values, our habits and beliefs, our ideas of a good life even, such as eating hamburgers, going away on faraway holidays, driving around in a car. These are all signals for us as freedom. On top of that, a growing body of literature demonstrates how powerful vested interests have developed a range of tactics to delay emission reductions, from discrediting climate science to lobbying and what else. So it is as important to understand what is causing emissions and the climate crisis as it is to know who is actually causing these emissions. According to a recent study, the wealthiest 1% of the global population is responsible for twice the emissions of the poorest half. Another fact that illustrates this inequity is that if SUVs were a country, they were the fifth largest carbon dioxide emitters. According to the IEA, the annual increase in emissions that can be attributed to SUVs in 2023 was about half the total emissions growth of the electricity sector. So, our way out of the climate crisis can never just be understood as technical solutions, all right? Look, for example, at the energy transition. Of course, we need to switch to renewables, but lithium is a crucial mineral for the production of batteries necessary for expanding electric feed and renewable energy sector. But lithium mines in Argentina, Bolivia, Chile are causing ecological disasters and social injustices, including the displacement of indigenous communities, huge water shortages, and immense ecological disasters. Another example, carbon dioxide removal. Carbon dioxide removal, such as bioenergy with carbon capture and storage. This requires massive amounts of lands to produce these energy crops, all right? And this is associated with biodiversity loss and food shortages, social injustices, displacement of people. So, what these examples show is that the climate crisis is not just a technical problem, right? So, it can also not be solved by technology alone. What we need is really a radical and rapid transformation. Because technology cannot solve the deep historic roots of the climate crisis, capitalism and colonialism. We really need to think about other ways of living and being and knowing. So, what are the current responses to this? So, in the context of international negotiations, the current response is the United Nations Framework Convention on Climate Change, the UNFCCC. So, you probably know about this. But just to recap, this process started in 1992 and it's still ongoing. One of the most historic moments was the Paris Agreement about 10 years ago, in which countries agreed to keep global warming below 2 degrees and pursue efforts to keep global warming to 1.5 degrees. So countries also agreed on the Sustainable Development Goals in Paris. These, rather than legally binding targets, countries define their own targets and strategies, and there's a whole monitoring process around it. And these targets are known as the nationally determined contributions, the NDCs. So, with regard to equity principles, there's the CBDR principle, which basically means that developing countries need to emit emissions first because of their historic emissions, which were far higher than developing countries in general. So it is now almost 10 years after the Paris Agreement, right? So in the context of the United Nations, the 2020s are often referred to as the decade of action. So a majority of countries now worldwide have set net zero by 2050 targets. And these targets actually come from climate models, which I will go into later. So not just countries, but also cities and companies have set climate targets and developed now their own strategies. So the second part of this lecture. Well, why is this all important to know? The context that I was just sketching. Well, climate models have actually influenced climate politics quite a bit through these scientific reports and scenarios. So in the second part of the lecture, I will tell you more about that. So I will explain what climate models are, how climate scenarios are used and developed, and how their interaction with climate politics plays out. So, what are climate models? Climate scientists often make this distinction between two types of models. In practice, there are more types and it's more difficult. But the first is Earth system models, which are highly complex representations of the climate system. Often they really need supercomputers to be run because they contain so much detail of the climate system. A second type of climate model is integrated assessment models, also known as IAMs. These are usually less complex. They combine multiple simplified models into one model. And the simplified models also include a climate model, a simplified climate model. So they can usually be run on a PC or laptop. This doesn't mean that they are simple, but just to sketch the difference. So Earth system models are usually used to develop climate scenarios. They look at how the climate system responds in response to different levels of carbon dioxide or global temperature. And they look at effects such as rainfall, droughts, etc. They're kind of like weather forecasts, but then over multiple decades and centuries. IMs are used to develop emission scenarios and mitigation scenarios. So, mitigation scenarios project what kind of socioeconomic changes are needed to reach particular climate targets, such as the Paris Agreement. Emission scenarios are more like exploratory and look at how emissions might develop in the future, not necessarily related to any particular target, but just exploring how it might change based on different socioeconomic developments. So, in this lecture, I will focus mostly on integrated assessment models because they are currently one of the most relevant tools to be used in climate policy. And this is also because the focus is in the past years more on understanding response strategies rather than understanding the climate system. So the focus is more on solutions, essentially. So IAMs are usually global models. There are also other levels, but the global models are most used in the IPCC context. And they are usually used to make long-term simulations between different socioeconomic developments. Socioeconomic developments could be like demographic developments, such as aging populations, economy, such as GDP, energy use, lifestyles, and so on. They usually combine different multiple simplified models into one modeling framework. This is just an example in this figure, but just an idea of what such a modeling framework could look like. And there are high variations between different IAMs in how precisely they do this and which models they connect and so on. So the most important way through which IAMs and policy kind of interact is through these IPCC reports. The IPCC is the Intergovernmental Panel on Climate Change, which was set up in the late 1980s. And over the past 4 or 5 decades, the IPCC has produced 7 large-scale assessments of climate science. So it's an assessment organization, so it's not producing research, we're assessing all the research that is out there, basically. One such an assessment was done only a few years back. So in these big assessment reports, hundreds of scientists work together to review thousands of published articles to assess the latest science on climate change. The IPCC consists of 3 working groups. Working Group 1 focuses on understanding the climate system, Working Group 2 on adaptation and impacts, Working Group 3 on response strategies. So IAMs are really the backbone of this 3rd working group on response strategies. The scenarios that are created in this working group are created by IAMs, all right? So that they're really crucial in that sense. So let's look a little bit into the history of IAMs. So most of the IAMs that we would call, IAMs today were developed in the early 1990s. Their historic roots go back to the 1970s, 1980s even, but the ones that are being used today, the first ones were developed in this 1990s period, also when the IPCC was just established, right? In 1988, and also when the UNFCCC was signed in 1992. So in the 1990s, their purpose was mainly to show how we might end up if we continue to emit carbon dioxide emissions. So one could say that their main goal was agenda setting. At that time, there was not really so many discussions about solutions or who should do what and so on. So in the next 2 decades, the purpose became more and more to also set targets. For instance, they could show what dangerous climate change actually means in terms of global temperature. So this is when the 2-degree target also came to the stage. Since the 2010s, more or less, they became more used to legitimize these targets, the 1.5-degree target and the 2-degree target. And in the past decades, they became mainly used to explore response strategies. So how could we actually reach those targets? The 1.5 degree, the 2 degree, and the net zero targets. And also to calculate to what extent our current policies are on track, known as the emission gap reports, which they are, well, usually not. um, but first, let's take a quick step back, actually. So, what are scenarios now, really? So, scenarios are often confused with predictions. So, I can't stress enough they are not predictions, all right? Why not? Well, most societal developments are just very hard to predict. Think of the internet. No one really saw this coming, or the mobile phone. Think about their position in society today, all right? Or COVID, the rise of far right governments, military conflicts. These are all quite unpredictable events, but they have great impact on emissions, in fact. So, scenarios are not predictions, but they can best be understood as thought experiments. Essentially, what they're doing is asking what if questions. So, for example, what if all countries shift to renewable energy? What if we would make carbon? What if we capture carbon from the atmosphere? Or what if we all stop eating meat? So, in practice, these questions are a little bit more complex. So, but just to give you an idea. Modelers often think of their practice as making maps. They're mapping out different pathways towards a particular goal and looking at what the different consequences would be. Um, so, how do they actually make assumptions? So, if you're a modeler and you want to compare models and scenarios, it comes in quite handy if everyone uses the same assumptions, right? Otherwise, things become just very difficult to compare. Therefore, modelers have developed this scenario framework, the so-called shared socioeconomic pathways, the SSPs. SSPs are very often used in climate science. They form the foundation of scenarios underlying the IPCC and are used by all three working groups. So the SSPs are basically storylines of global developments, which are then translated into quantitative parameters of many variables, such as GDP, lifestyles, urbanization, international cooperation, markets, and so on. So the structure of this scenario framework is rather simple. It's a 2x2 scenario matrix. The key difference between the scenarios is two things, basically. So how challenging it would be for adaptation, climate adaptation, and the challenge to mitigation. So I don't really have time to go into detail, but essentially SSP 5 is highly unsustainable scenario with high fossil fuel use, whereas SSP 1 is among those the most, let's say, sustainable scenario, and SSP 2 is more like in the middle of the road scenario. So now I show you what this looks like in actual IPCC reports. So this is a figure from the most recent IPCC assessment. And you can see that here the purple and blue scenarios show the ones that are in line with the 1.5 and 2 degree targets. And the red line shows current policies. So here you can see a huge gap already. And then within these blue and purple plume, there are different scenarios, including SSP1. So these are mitigation scenarios, assuming that either current policies continue ending up with higher emissions or a lot more action is needed where we reach our climate targets. You see here also that not only the SSPs are used, but also some other scenarios to make it a bit more complicated even. So what is really important to notice here is that the scenarios that are in line with the Paris Agreement, so the blue, purple ones, all assume that at least some of that mitigation is done through carbon dioxide removal. So these net zero scenarios do not mean necessarily that no carbon is emitted in the atmosphere anymore, right? It just means that the amount that is emitted and the amount that is captured equals zero. So all these scenarios assume that some of the mitigation will come from carbon dioxide removal. So they assume that carbon dioxide removal is necessary to reach the climate targets. So this is important to know because remember what I said earlier about these adverse consequences for biodiversity, food security, social justice, and so on. So now that you know the context of the climate crisis, its root causes, its politics, and you know a little bit more about how IAMs are used in climate policy and the IPCC, let's move on to the third part in the lecture, in which I bring these together. So with these root causes of the climate crisis in mind and the need for rapid and radical transformations that are also just, the question is really whether we should rely so much on IAMs, because IAMs have many strengths, right? They can represent highly complex systems, but also many limitations. So in this lecture, I will focus on 3 of those limitations that I find particularly problematic. So the first is that IAMs tend to emphasize pathways that are in line with green growth. So the SSP1 that I was showing, which is considered the most sustainable scenario, is a green growth scenario, meaning that it is assumed that mitigation happens in the most cost-effective manner, that economic growth will continue forever, and all these scenarios also rely on this unproven technology, right? This carbon dioxide removal. So it's really questionable whether IAMs explore transformations or just a continuation of the past, right? Think about that. A second problem is that they are completely misaligned with equity. Because IAMs assume that mitigation should happen where it is the cheapest, they automatically assume that developing countries would need to reduce first. This is absolutely outrageous if you think about it. Developing countries often rely more on coal compared to oil. So the scenarios assume that replacing coal would be cheaper. So in essence, they assume that developing countries should emit their emissions first. And this is completely the opposite of what was agreed in the Paris Agreement, which is that developed countries should take the lead in emission reductions. Okay, third, IAMs were designed for informing climate policy, right? And because of their global scale, their main outlet, let's say, is the international negotiations. But we all know by now that after decades of these negotiations, they're really not sufficient to get us out of the climate crisis, right? I'm sorry, but they will not save the world, basically. But when you look at climate action across the world, a lot more is actually happening than just these international negotiations. So climate action happens on many scales, national, local, regional. It also happens by so many more means than just policy, right? It happens through grassroots initiatives, global movements, community actions. So on the one hand, this is of course great news. But what it means is basically that IAMs are not very good at taking these kinds of actions into account because they tend to focus so much on technology and market-based instruments. So what it means that because IAMs are so prominent in shaping what is being discussed in policy discourse, it also means that these other types of actions that are more radical also become unimaginable in a way. And secondly, for these other types of actors, such as city governments or non-state actors, such as NGOs, civil society, local communities. It's also really questionable to what extent these scenarios are really relevant for them. So let me now come to a conclusion. I started this lecture with this quote. Everything we know about the world's climate, past, present, and future, we know through models. Now that you know why climate models have become so prominent in understanding the climate system, and you have also learned how integrated assessment models have become so prominent in not just understanding the climate system, but also how we actually respond, how should we actually continue to think about them? Because they have so many limitations, which also questions their relevance for actually exploring futures that are radically different from the past. They're also quite unfair from an equity perspective. So I invite you, whenever using IMs, and I think you will do in this course, I strongly invite you to always consider, where do these assumptions come from? Who do these scenarios benefit and who do they burden? Whose voices are heard and whose voices are not heard? And are they constraining or helping us moving towards a more sustainable and just future? Thank you.